Good morning, all of you. This is the 12th class, 12th lecture of course ME 501 internal combustion engine. In this class, we will discuss about real cycle analysis. In last class, we have seen various air standard cycles, that is Carnot cycle, Otto cycle, diesel cycle, and Dewey cycle. In this class, we will study real cycle. What is real cycle? So, what we will study in this class, we will see the comparison of air standard cycle and actual cycle, and we will see that this actual cycle is also called real cycle. Okay, so what are the main factor by which this air standard cycle is differ from this real cycle? That is time loss factor. We will study. We will look at direct heat losses factor, and we will also look at exhaust blowdown losses factor. These three factors are the major difference between the air standard cycle and actual cycle. We will look this into detail, and we will see the effect of this factor on the PV diagram. Okay, so first we will start off with actual or real cycle. So what is the difference between actual or real cycle? There are various difference between the two. First is the working substance being the mixture of air and fuel. In air standard cycle, we consider that the working fluid is only air, but in actual cycle, it is a combination of air and fuel. Okay, with and it is also combined with the exhaust gases, little amount of exhaust gases or the product of combustion which is left from the previous cycle. So actually, what is the combination? It is a combination of fuel. It is with air and some amount of exhaust gases as well. Okay, but what we consider in air standard cycle, we only consider that it is only air. The other difference is the change in chemical composition of the working substance. Again, we assumed in air standard cycle that the chemical composition will remain constant throughout the process of combustion. But actually, it is not the case. Here, fuel burn and its chemical composition changes, and because of that chemical composition change only, we will be able to produce energy. So, chemical composition continuously changes of working substance in actual cycle. Again, the variation of a specific heat with temperature. In air standard cycle, what we have assumed? We have assumed that the specific heat will remain constant throughout the process of combustion or throughout the process of cycle. Means all the four stroke, yeah, or two stroke in two stroke cycle, the specific heat of the working substance will remain constant. But it is not the case. Specific heat is very much dependent on the temperature of the system. As the temperature increases, specific heat also increases. So this is the criteria that we have to take while studying actual cycle. Next is the change in composition, temperature, and actual amount of fresh charge because of residual gases. So, in actual air standard cycle, we are not considering the content of residual gases which is present in air fuel mixture, but actually it is present. So, because of the presence of residual gases, the amount of actual charge which is intake is reduced. It is not theoretically what we are calculating that this much amount of charge are taking inside the combustion chamber, but practically it is not possible. In actual cycle, it is not possible because some amount of exhaust gases are already available there, are already present there. So it restricts the actual content of air fuel mixture to come inside the combustion chamber. Again, the most important thing is what we consider. We always consider that in air standard cycle, we consider that the combustion is an instantaneous process. But actually, it is not an instantaneous process. It is a progressive process. Means combustion requires some time, but what we have seen in Otto cycle, we have seen that the process of combustion at constant volume. Heat addition occur at constant volume. Means piston is at top dead center. It is not moving. It is not moving. What does it mean? That it is an instantaneous process. It does not require any kind of time. But actually, it is progressive combustion. Next, the heat transfer to and from the working medium. In ideal cycle, we consider that there is no heat transfer from the working medium to outside, but actually it is not possible. We are using cooling arrangement. So heat transfer occur between the working substance and outside of the engine. Next, the substantial exhaust blowdown loss. That is the loss of work on the expansion stroke due to the early opening of the exhaust valve. In case of valve timing diagram, what we have seen that we are opening the exhaust valve before the power stroke end. So what is happening out here? Because of that, there is a loss of work, and that loss of work will be considered in case of actual cycle, but in case of ideal cycle, it is neglected. Again, important that there is in actual engine there are some gas leakages, fluid friction, etc. are there. There are some frictional power losses, but in ideal cycle we are ignoring all those things. Most of the factors listed, this 8 factor listed, either it will decrease the thermal efficiency or power output of the actual engine. So because when we are moving from air standard cycle to actual cycle, what we will see that either the thermal efficiency will be decreased or the power output will be decreased. Okay, so actual cycle will give less thermal efficiency and less power output as compared to the ideal cycle. Okay, so out of those all those factors, what are the factors which are of major influence? सबसे ज़्यादा influence किसका होता है? So we will see that the first is time loss factor. In time loss factor, what is happening? Loss due to time required for mixing of fuel and air, and also for combustion. So it is because of what we have discussed that combustion is not an instantaneous process; it is a progressive process. It will take some time. So because of that time, some loss occur, and this loss comes under time loss factor. Loss due to time required for mixing of fuel and air, and also for combustion. Next is heat loss factor. In ideal cycle, what we consider, there is no heat loss, but in actual, heat loss from the gases to the cylinder wall took place, and this has to be taken care in case of actual cycle or real cycle, because of this, lot of energy goes out of the combustion chamber without being converted into mechanical work. And the last one is exhaust blowdown factor. Means we have seen that in valve timing diagram, that valve opens before the piston completes its power stroke. So because of that early opening of valve, exhaust valve, there is a loss in expansion. Expansion stroke work will be reduced. Whatever the power is transmitted, whatever the work is transmitted from the gas to the piston, it will reduce because we have opened the exhaust valve, and some amount of energy is going starts moving out of the combustion chamber before the power stroke ends. So these are the three major factor, that is time loss factor, heat loss factor, and exhaust blowdown factor, that differentiate the actual cycle with the ideal cycle. So we will discuss all these three factors, that is time loss factor, heat loss factor, and exhaust blowdown factor in detail in our next class. Okay, so stay tuned for my next class. Thank you.